Welcome back to the Algebra 2 PLC special edition around the problems from the semester exam review packet. We've received some questions via email. In this segment, we're going to be focusing on the cluster of questions from problems 44 through 47. I'm James Key with the MCPS math team.
And I'm John Chase, an Algebra 2 teacher at Richard Montgomery High School. Thanks so much for being with us. And let's just jump in. Let's take a look at 44 and 45 together. Let's look at what even functions mean for our lives. The point 3,8 is on the graph of an even function. Well, what does that mean for my life? Well, 3,8, I got a nice picture here. 3, 8 is on an even graph. And actually, let's be mavericks again. And let's think about question number 45 before we answer 44. In fact, maybe they should have come in that order, right? We need to understand maybe what an even function means in order to answer this first question. So by even, we mean a function that has symmetry with respect to the y-axis. So here it is. I'm just highlighting the y-axis. And by symmetry with respect to the y-axis, I mean reflectional symmetry with respect to the y-axis. So we need a point over here that's equidistant, forming the perpendicular bisector of this little segment that we've just drawn. And now all that remains to be seen is that we name that point. Now we're ready to answer question number 44. That point is -3, 8. And the answer to 45 is, again, let's just say it again, is symmetry with respect to the y-axis. Or there are a couple good ways to say that. You could say reflectional symmetry with respect to the y-axis.
All right, and having looked at an example of what can go on with an even function, let's transition over to a discussion of what can happen with the odd functions. Let's do it. Okay, in problem 46, students are presented with the information that the order pair 5, 7 is on the graph of some odd function, and then they're asked to describe the symmetry of the graph of an odd function in general. Okay, so as John did, I'll just start with 47. I know that odd functions are a generalization of the behavior of odd power functions. X to the 3rd power, x to the 5th power, x to the power of 917. Any odd power is going to have a particular behavior like this, where there's symmetry with respect to the origin. So knowing that this graph, and again we're given that it's odd, we've got the ordered pair 5, 7. And knowing that this graph is symmetric with respect to the origin, we can go over here to -5, -7. And regardless of what this graph may look like, and it could look like just about anything, maybe there's a wiggle there. Can I make that wiggle happen symmetrically? I hope so. All right, this graph could look like many things, but we know that it must pass, since it passes through the point whose coordinates are 5 and 7, it must pass through the point whose coordinates are -5 and -7 because of the fact that it's an odd function. All right, so again, as John did, I'll just write out my response to question 47. The graph of an odd function is a graph that has symmetry with respect to the origin. All right, this has been a special edition of the Algebra 2 PLC, where we've looked at some questions that have come up via email around problems in the Semester A exam review packet for Algebra 2 students. We sincerely hope that it's been helpful to you, and we wish you the best as you prepare for the winter break and as you prepare to help your students prepare for their semester exam. Thanks for tuning in.
Thanks, guys.